Hey guys, this is Fred from Pretty Fly Games, and this is a new series on how to build an endless driving game in Unity. My Patreon supporters have asked me how I made certain parts in Pixel Driver, an endless driving game available on PC, Xbox, Steam, PlayStation and Nintendo Switch. So it's time to reveal the secret sauce, so let's get started. I've created a new project for this, and it's just an URP empty template, so it's nothing fancy. Let's start by deleting the README, tutorial info and the scene. And for this project we're going to use models from Kay, so let's download them from itch, the link is in the description. We are going to use the Halloween bits and the city builder bits, so download those. I've downloaded the models and extracted them and put them under models, so now we can start to create our endless driving game. And what we will start with is an empty game object, which is going to be a section. So each section is going to go in this direction. This is our forward, the blue arrow, and let's just make sure that it's centered just on 0 first. So this is going to be section, and under it we want to have some type of ground. So let's do a 3D object, and it's going to be a quad, and we can parent it to the section, and then we need to rotate it so it's actually flat on the ground, and as well just center it, and then we need to scale it. So in the X direction, I don't know, let's start with 50, and then in the Z direction, as we have flipped it, it's going to be actually the Y, so it's a little bit confusing, but that's all right. So let's go with 26 maybe. So this is going to be one section, and for our endless runner, so this section will be created and stacked after each other, and that gives us the ability to create a sort of unique environment for each section. So now that we have done that, let's create some material to make it green, so it's some type of ground. So let's do a folder, materials, and then let's make a material, and we'll call it ground, and let's make it green, and then we can drag and drop that. And we don't want it to have too much smoothness, because it's just going to reflect the light, and it's going to look a little bit strange. So we want it to be very sort of non-reflective, so let's leave that as that. Okay, so now we have our section, we have our quad, let's rename it to ground. And then we want to have our road, so let's create a new child and call it road. So if we look at our models, we have the builder bits, and in it, under the assets, we have FBX Unity, which is the ones that we are going to use. And we have a road straight, it looks great, so let's pick that one, and let's add that to our object here. So now we have that, and we want to use that for the whole section, and the easiest is actually to enable our grid snapping here. So let's enable that, and make sure that it's set on 2, and then we can just duplicate this and fill out the whole section with that. Oops, I grabbed something else. Alright, so let's fill that out. Okay, so there is however one part of this road here that we want to change, and when we are using our runner, we are going to fake all the car physics. We're not going to use the built-in physics, so that means that we have to flatten the road. So let's take our road here, and let's change this to 0.1 instead. So now it becomes quite flat, because otherwise the car's wheel will just run through the ground, and it will look a little bit strange. So that's our section here, and already we should start to think about optimizing this, because we want it to be able to run at a very high speed, and we don't want to have any sort of jitter or lags in the game. So let's mark all of our objects here, and let's remove cast shadows, because, well, there don't have to cast any shadows on the ground, because we won't hardly see them anyway. So the same goes with the ground. Let's remove cast shadows. So that doesn't need to cast any shadows either, because we don't have anything under it. So as well, why does it look like this? We can see the wireframe, and it's because I've selected shaded wireframe. You can just have it as shaded, but I usually like to have shaded wireframe when I'm editing the scene to see how everything sort of aligns and things like that. Alright, so now the next thing is to create the car. So let's create again an empty game object. Let's put it at 0. And then we will call this car, and under it we will have a model, and in here we're gonna drag and drop our model. So let's find a car, hatchback, police, sedan, hard choice. I think that will go with a hatchback. It looks very cool. Alright, so let's drag and drop that in here, and it's at 0, so it's in this dead center of our scene. So that's good. So it's going to be driving in this direction, and as I said before, we are going to fake all the physics to make it run faster, and also it will be easier to control, because when we are driving the car like this at extreme speeds, we actually want it to sort of sway. Oops, hold on. Let's unlock that. We want it to be able to sway sideways. If we would use a regular physics car, it would actually turn a lot more, and it would be hard for the player at very high speeds to be able to actually control it and make sure that we are staying in our course, which is going to be a sort of a straight line. We can create some turns, but not a lot, because it's sort of faked, and we want it to be driving in this direction at all times. Alright, so let's move it back to 0, and our car, if we have a look at it, let's actually let's reduce the gizmos, and we have, why did I duplicate the global volume? There we go. So here we have it, and it's actually sitting below the ground. And let's bring up the whole model, because we want the car to be at 0, and we can just bring up the model to something like that. So now it's actually sitting on top of the ground. Okay, and if we look at our model, it consists of the different wheels, and there is this chassis part. So the chassis part is what we're going to use to detect collisions. So let's add a mesh collider onto it, and let's make it convex, because otherwise we can't have it as a rigid body. Okay, and then on our car's main root object, let's add a rigid body to it. And we are going to constrain it. We want it to act as a rigid body in some senses. We want it to be able to drive forward, and that's roughly about it. We want it to be able to move to the side and go back, well, forward at least. And we don't want it to rotate, because if we are hitting something, it will sort of spin like this maybe, and that's not behavior we want in this case. So let's freeze our position here. We don't want it to go upwards in the y direction. We don't want it to ever leave the ground. If we are going to add jumping maybe later on, then we would actually cheat and move the model. That would appear like it's jumping, but the actual main object here is going to be on the ground. And then we are going to freeze our rotation. So our rotation is going to be actually frozen in all directions. So the rigid body itself cannot move or rotate. It's going to be fixed. And the wheels, for now, we are actually not going to bother with adding anything to them, because they won't be detecting the ground at all. The car will act actually as like floating above the ground at all times, and it will keep the height or whatever we set it to, which is going to be 0 regardless of what happens. One important part though is that you will need to interpolate it. So change interpolate to interpolate, because otherwise it's going to be looking like it's lagging, and that's not something that we want. Then let's create a folder for our scripts. So we call it scripts. And then let's make a new folder, call it car. And in that, let's make a C# script, car handler. And let's open that in Visual Studio. Okay, so the first thing we want to do is be able to drive the car forward. So let's add a serialized field and rigid body so we can access the rigid body. And we are not going to use update to move our rigid body, because that's something that you do in fixed update instead. So let's add a void fixed update. And in it, we want to be able to accelerate. So let's add a new function for that, void accelerate. And our accelerate will handle the sort of accelerating the car. And the first thing we want to do when we are accelerating the car is to ensure that there is no drag. So we want it to not slow down when we are trying to accelerate. So let's remove our drag from our car. And then we are going to push our rigid body. So let's do rigid body force. And we are going to push it in the forward direction. So let's do rigid body transforms forward. And then we want to have some type of speed. What speed is it going to move at? So we could write something like 10. And then we need to have some input so that we know that okay, the user is pushing forward. But instead of hard coding all the variables, let's actually create some variables for it. So we want to be able to have some type of multiplier here, which is going to be our acceleration. So let's create a float acceleration multiplier, put it at 3. Hopefully it will be a good value. We'll see, we can change it later. And as well, we need some type of input from our user. So let's add a vector2 for that. So vector2 input, and it's going to start at 0. And the input is going to be in the Y direction. So when somebody's pressing like the accelerator button, then we will increase our Y variable here. Okay, so this will push the car forward. So let's call accelerate here. So if we would run this now, it would actually stand still, and because our input is not being set anywhere. We could add our sort of buttons here in the update and collect and poll for them, but we want to be able to use this sort of script as well for our AI. So we are going to have an external script that collects input and actually sets it, because then we can reuse the same code for our AI. Then let's do the reversed. We want it to be able to brake. So let's add a new function, brake. And our brake is going to be a little bit special, because we don't want our car ever to be able to reverse. We are going to build an endless level that is going in the forward direction, and if we allow the player to go backwards, then, well, we're going to be in trouble, because we are sort of going to delete everything behind the player. So we are not going to allow the player to reverse. You could allow the player to reverse a little bit, but not too much. But for now, we're actually not going to allow it at all. So how are we going to do this part? Well, we're going to do it exactly as we did up here, but in the reverse direction, which is going to be that our y is going to be negative. And we need a brakes multiplier. And let's add a float for that as well. Float brake multiplier. And we want to be able to brake very quickly. We don't want actually our car to take too long to brake. So I think that we will try with a value of 15. That's hopefully will be enough. If we're driving extremely fast, we might need to increase this or modify it, but let's start with 15 and see what happens. So when are we accelerating? Right now we're trying to accelerate at all times, which is interesting, but not what we want. We want it to be able to actually only accelerate when our input is larger than 0, right? So let's add that as a condition. If our input is larger than 0, then accelerate. And if it's not accelerating, then actually let's apply some drag to it. So that will mean that when a player lets go of their buttons, then it will slow down automatically. And then as well, we want to be able to apply brakes. So if the input is large or smaller than 0, then let's brake. And then we want as well to be able to steer the car, right? So let's add a function for that as well. And there we go, steer. And we will call this as well in the fixed update. So after we've done all our acceleration and braking, and then let's actually try to steer the car. And we want to try to steer the car if there is some type of input. So we're looking at the X and we're doing the abs, which checks gives us removes the minus or plus, and it needs to be larger than 0. In that case, somebody's pressing the button. And then we want to be able to move our car in the sideways direction. And so how will we do that? Well, we will do it in exactly the same way that we did it with our acceleration and brake. We actually won't rotate the car with this. So let's add a rigid board force, and we will add it towards the rigid body transform right, so the right direction. And then we will need a multiplier again, and we will need a steer input multiplier. So we will add that later on. And same as this one, times y, but times x. And let's add our steering multiplier. And a suitable value for that, I'm going to look actually in my cooking book to see what I used. And I actually used a value of 5. So let's go with 5. All right, so now we would have some type of movement for the car, but we need to be able to provide some input as well. So we need to be able to set our input somewhere. So let's add a public set input so we can access it from other scripts. And we are going to do, all right, input vector. We are actually going to make sure that nobody is cheating. So we're going to normalize it to make sure that it's actually between -1 and 1. And then we are going to set it like it proposed. Okay, so that's cool. That is, I think, enough to get started with our car. So then we need to collect the input from the player. So let's create a new script, go under assets, script car, and right click, add new item, and car input handler.cs. And we can actually have it as an empty object here, which maybe I shouldn't have done, but at least let's do that and call it input handler. Oops. Input handler. and it's going to be a mono behavior. And actually, let's copy this part. So that was another way of creating a new script, and we could have used template, which would have probably been better. But anyway, so we need to access our car handler here. So let's use a serialized field car handler. Then we have that, and then we are going to do an update. So in our update loop, we are going to get the input from our player, and before that we need a vector for it. So we're going to have a vector2 input, and then let's get our horizontal input and put that in our x value, and our vertical input, let's put that in our y variable. And then we are going to do car handler set input with that vector, but we are going to add one extra key, and this is always good, I think, when we are doing like endless driving games and, well, games in general. Let's have a reset function. So whenever we're pressing R, let's reload the whole scene, and to get rid of those errors we need to be using scene management. Unit engine scene management. Okay, so let's save that and let's go back into Unity. Then let's select our car and drag and drop our car script and our input handler. And as well, drag our car into the rigid body and our car into the car handler slot of the input handler. Okay, so let's save our actually scene. So we have that somewhere. Scenes, and let's not call it sample scene. We'll call it stage, because we might. Yes, there we go. So and then let's just try it and see what happens. Alright, so our car is very far away, but we can see that, okay, we can drive, we can go sideways, and it actually doesn't stop either. When we let go of our keys, it's just gonna continue forever. And well, in the forward direction, at least it is stabilizing itself eventually. So our car is, well, driving along happily here. So, well, that's good enough for as a start at least. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.